Hello everyone. In this video, we will talk about two new machine models available in version 2022.2 of the Typhoon Control Center, the Open-Winding Permanent Magnet Synchronous Machine, or Open-Winding PMSM, and the Permanent Magnet DC Machine, or PMDC. These components further expand our vast library of pre-built machine models, designed to help you get started with a high-fidelity, control hardware-in-the-loop testing as quickly as possible. The Open-Winding PMSM is useful for high-power applications commonly encountered in the automotive area. By having both stator coil terminal sides accessible by electrical ports, this topology can reduce the voltage stress applied to converters connected on either side of the machine. While including another component in the driver makes the control more complex and may cause additional issues during operation, the real-time simulation of the Typhoon HIL toolchain is specifically designed to address and resolve these issues prior to physical testing of the machine. The control hardware-in-the-loop approach is also useful for low-power applications like servos or actuators, where the precision of the velocity and position are key requirements for control. In this context, the new PMDC component was developed to accelerate the control design process of these applications. As its name suggests, the PMDC component differs from existing DC machines in the field winding, which is substituted with a permanent magnet. Now, let's look in Schematic Editor to see how you can find and configure these components. You can find both components under the Machines tree in the core library of Schematic Editor. The Open-Winding PMSM can be found under the Synchronous Machine category, and the PMDC is under the General Machine category. Through the component's properties, you can specify the electrical and mechanical parameters of the machines and configure the interface with an external system. You can define the source of the load applied on the axes of the machines as either by the model or by SCADA or external device. When set as by the model, the load must be modeled using signal processing and fed to the newly created signal processing input. For SCADA or external sourced values, the load values are either defined by an analog input on a connected HIL device or by HIL SCADA, where parameters can be set in the Machines section of the Model Settings dock. You can also define the machine's output signals in the Output tab. One signal processing output will be created in the component in this case. Under the Feedback tab, encoder and resolver settings can be adjusted. As previously mentioned, the poles of the stator of the PMDC machine are formed by a permanent magnet. For this reason, two new parameters are introduced in the model dynamics: the torque constant, kT, which defines the torque speed characteristics of the motor, and the voltage speed constant, Ke, which represents the relationship between the motor's back EMF and its speed. Those are the key features of the new machine models available in the 2022.2 of the Typhoon Control Center. Thank you for watching.